Now we are going to look at solution code for the disastrous downtime problem in C++. So I'm going to use two slides for the code. This slide include the template code which are used when I write C++ programs for competitive programming. So the first line it's a G++ compiler sort of shorthand to allow you to include essentially anything you're going to need from the standard library. So you don't have to have a long list of include, just use this one line. And by using the std namespace, we can use a lot of predefined functions and variables without having to write std : to, in using the namespace notation. Here, this is, I guess I should say this part is optional. If you are not using C++, you can skip this video. And I assume you already know a little bit C++ if you are watching this. I'm not going to explain everything sort of from the original details. So then to enable using type names, data type names in a short fashion, so we have this defined field shorthand. So this is actually only a part of my template, only the part that's sort of relevant for this problem. The template also defined the shorthand for long, which is needed when we need the longer representation for integers. But we have a vector of int, and then so that's one-dimensional array, and we have a vector of int, so this is a two-dimensional array. And then there's a very useful type pair, which is you can associate two types. So essentially, you can view it as a in this case, you can view it as a two element array because both of them are int. But you can have different type here in this pair. And one thing that is useful is there's a built-in order in pairs where you first compare the first part and then you compare the second part. So which is oftentimes exactly what you want. So for example, you do not need a separate code for sorting to the array. You can directly using sort with the pairs. And then this a bunch of macros. So this is just for shorthand. REP is just something that you may use very common. And RE, this just says repeat B times. So this is when you don't really need a loop variable. You're literally just repeating a number of times. You can use this macro. Traverse enable you to loop through all elements in X, and then that element will be put in A. So A will be instantiated with each of the elements in X. And this reference, this ampersand means reference. It's important. By the way, this auto is means that the compiler should be able to figure out the data type of A from X, because knowing X data type, you know what are the elements of X data type. So then I don't need to think about what is actually the data type. I can just use auto here. And this ampersand is a reference, so that means we're not actually making a copy of each element in X into A. So A literally just refer to the element, each of the elements in X. And the macro all X will just means before X, from before X to end X. And we're going to see a usage of this in the code. And size, this is just shorthand to get the size of a collection. So this is the code for solving this problem. This line is the C++ input speeding up. And yeah, so we read in n and k, and then we are creating a vector of a pair of two integers of size 2n. And then each time, so then when we're reading data, we actually just repeating n times, because we're just really reading n piece of data. I don't really need a loop variable I to change. So we'll read in data into X, and then add the two events, two pairs. So the first one is x1, the second one is x plus 1000 -1. So add this to the vector. And then I use a sort. So this is I could use sort times dot begin parenthesis times dot end parenthesis. So this is just slightly shorter. And then here the logic, I use the one that I mentioned last time, where we can just calculate the maximum number of requests at any time, which is be keep into variable MC, and C is keeping the number of requests sort of going on. So then the loop is where literally we just need to traverse over all the element in this times. I guess maybe it's better to call it events, but that's okay. So for every pair, the second one is +1 or -1. We add that, and then we just keep track of the maximum one. So, and when this loop is done, MC stores the maximum number of requests at any time. So to get the number of machines that are needed, we need to divide by k. But because the integer is division, even if we have one more than say, even if we have just k plus 1 requests, we need 2 machines. So the standard logic to handle that is you add the k minus 1 and then use integer division, divide by k. So in these topics, the main concept are prefix sum and prefix sum array and the difference array. So prefix sum array makes answering query about the ranges more efficient. So if we have update at individual positions and queries about the ranges, then we want to use a prefix, a query of sum about ranges, we want to use a prefix sum array. And if we want to update ranges, and then we have very few query to answer, so essentially only query at the end, then we want to use a difference array. So prefix sum array and difference array are sort of dual to each other. So if you learned calculus, you can almost think prefix sum array as calculating the integration and difference array as calculating the derivative. But that's just really a connection. It's not needed in order for you to understand this concept and to use them. Okay, so that wraps up the topic 1.